Alright guys, in this video we're going to be looking at some net ionic equations, short answer questions. So while investigating the chemical properties and chemical and physical properties of a metallic element E, the student conducts an experiment by combining E in the solid state and HBr in the aqueous state, which react accordingly to the equation below. Write the net ionic equation for this reaction. So this one we're just writing the net ionic equation. There's a couple ways we could do this. You could just write the complete ionic equation, turn all of these compounds in this equation into ions, and then just leave out take out the spectator ions and then write out the net ionic equation. But obviously for the AP test, we want to save time where we can. So what I recommend is looking at the reaction that we have that's been given to us and find the parts and the ions that are going to be the same on each side. For example, E here is a solid, so it has to be part of the reaction. There's no ions that will be on both sides. In this one, we have either a hydrogen or a bromine that is an ion, and it could be part of the reaction or it might not be. Here also we have some ions, and then here we have a gas. So the only element that is the same on each side in the same state of matter is the bromine. Bromine is in an aqueous state on both sides. So this is the one that we want to leave out of the equation when we write a net ionic equation. So I'm just going to bring everything else down. We have an E solid plus 4H plus hydrogen ions. Hydrogen forms +1 ions. And that goes to form an E aqueous state. Aqueous. And the charge we can determine based on what we have here. This is going to form a +4 charge because the bromine is a -1 charge and there were 4 of them. So this will be a +4E aqueous state plus 2, there's a total of 4, but 2 hydrogen gas molecules. And make sure I put a gas there. So this would be the net ionic equation for this given reaction that we were given. Make sure this is in the aqueous state. Don't forget the states matter for everything that you have there. Okay, anything that's metal in the solid state has a charge of 0. Okay, and in the aqueous state, they're going to probably form plus charges. Like this one's going to be a +4. Okay, looking at another one, we have another reaction. We have calcium carbonate plus hydrochloric acid to form some products, including calcium chloride, carbon dioxide, and water. And once again, we want the net ionic equation. To save time, we're going to do the exact same thing I just did. I'm going to be searching for the things that will be the same on each side. The calcium right here goes from a solid to an aqueous state, so that's got to be included. Carbon and oxygen, they're going to end up as carbon dioxide and water. They're changing states of matter as well, so that's part of the reaction. The hydrogen here is aqueous, and then the hydrogen here turns into a liquid for water, so it's got to be part of it. The only thing that is the same on each side is these calciums. Didn't mean to go over the aqueous. The chlorides, sorry, not calcium. The chlorines. The chlorines are aqueous state on each side, so that is the only spectator ion. That's the only thing being left out of this reaction. So we have CaCO3 solid state plus 2H plus ions, hydrogen ions. That's the aqueous state. We'll go to form a calcium 2+ aqueous state. The calcium is a 2+. It's a alkaline earth metal. Also, we can see here chlorine forms a -1 charge, and there are 2 of them. And then that will also form carbon dioxide in the gas state. It's not an ion, so it won't break into its ions. And liquid water also is not going to form ions. So this would be the full net ionic equation for this reaction.